Hi friends, greetings. This is a continuation video of the network analytics concept. As part of this video, we will try and understand how do we represent the network data in a very structured format, right? So that our computers can also understand the data and help us to perform certain computational formulas. We need to derive insights, and for that we should be able to apply mathematical and statistical formulas on this particular network data. But when you see a network like this, where you see nodes and connections between them, we will not be able to really process this data using any mathematical concepts directly. So what we do is we create a structural representation of this network in a two-dimensional form, that is in a matrix. This matrix is called as adjacency matrix, and this is the default representation for our networks. It's very simple representation. It talks about whether there is any connection present or absent between a pair of nodes. So let us try and understand how these graphs are actually created. Now, as we discussed, there are two types of edges or connections. One is directed and the other one is non-directed or undirected edges. So let us start with the adjacency matrix for undirected graphs. Let us assume we have a graph or a network. So I'll say A, B, let's say C, this is D, and let's say this is E. And I will try and establish the connections between them. A is connected to B, B is connected to C, C is connected to D, and then let's say A is connected with D, and E is connected with both A and D. So let us assume this is our network, and let's say A is also connected to C. This is a very simple network diagram that we are seeing. Now, how do we represent this data in a matrix form? So here we take the nodes or vertices as the matrix labels for both rows and columns. So I'll say A, B, C, D, E. So here I'll represent each row with the node. Likewise, I'll create a columns set which represent our nodes. Now, if there is a connection, then we will say the value is 1. And if there is no connection, then we will put the value 0 in. So A is obviously not connected to A. It is a single node. And remember, we said edge will exist when there is at least 2 nodes available. Only then can an edge exist. Of course, we will have a loop, this loop kind of a network also, where if I say A and if it is connected to A like this, then this is a loop connection. But here I don't see such loop, right? So that means A is not connected to A. But A is connected to B, so I'll mark it 1. A is connected to C, A is connected to D, and A is also connected to E. This is how we represent the connections using binary data, ones and zeros. Then, if I now consider B, node B is connected to A. So I will represent 1, B is connected to A. But B is not connected to B, I'll put 0 there. Next, B is connected to C, yes. But B is not connected directly with D. So I'll put 0 here. And B is not connected with E either. So this becomes 0. Likewise, C C is connected with A, C is connected with B, C is connected with D as well. C is not connected with C. C is not directly connected with E, so I'll mark 0. Next, with respect to D, connected with A, but not with B. With C, it is connected, and with E also it is connected. And finally, we have E, where we represent connection as 1, A and E 1. B and E is not there, right? So I'll put 0 here. Then C and E also not there. We have D and E connection, and E is not connected to E. So this is a matrix representation for our network. And remember, we are talking about undirected graph. So when we talk about undirected graph, that means the edges that we have here do not have direction. In this case, the adjacency matrix will be symmetrical in nature. Okay, we'll get symmetrical matrix. And you can clearly see that if I cut this matrix at the diagonal, you will see the mirror image of the values on either side of this diagonal. Upper triangle and lower triangle are exactly same. So this is nothing but your symmetrical matrix. This property holds good for undirected graph. Now, this is basically a graph, but we also have something called as a directed graphs, right? Digraphs. This is a graph where we're not talking about any directions, but if I say a directed graph, then we will have a different values altogether in the adjacency matrix. Again, I'll take a very small network. I will say A, B. So A is connected to B. Okay, and then I'll say there is node C. C is connected with A. And then let's say I also have D and E nodes. Okay. Whereas A is connected to D, but E is connected to B like this. E is also connected to B. Okay. And between DC, let's say C is connected to D. So I'm basically putting directions, right? And let's say E is also connected to D. I'm putting specific arrows. You'll have to observe the direction of the arrows here. Very important. Okay. So inward connections and outward connections you can see. Now, if I have to represent this particular data in a graph, then again I'll say A, B, C, D, E. A, B, C, D, E. A is not connected with A, of course. A is connected with B, yes. A is connected with C, no. Remember the direction. A is not going to C. C is coming to A. So this becomes a 0. A and D, if you see, yes, A is connected to D as well. A and E, there is no connection. Likewise, if I say B, B is not connected with any of the other nodes. There is no outgoing arrow, right? Outward connection is not there. So D is not connected with any node. Only inward arrows are seen here. All right. Next, we'll talk about C. C has again outgoing connections to A and B. And I also see D as well. There's no connection between C and E. Then with respect to D, Again, I don't see any outgoing connections from D, so I'll put zeros here. And finally, with respect to E, I see outward connections from E to B and E to D. Right? So now you can see the graph is not symmetrical. This is non-symmetrical graph. Okay? Or matrix. So this is how we try and represent the data in a numerical representation. Now, once the network are represented in adjacency matrix format, we will be able to use this two-dimensional data structure, that is your matrix representation, for mathematically or statistical computations to derive insights on the network. Hope you enjoyed the session. I'll see you in the next video. Thank you.